Hi, hello guys. I'm going to discuss about stereochemistry. So the study of three-dimensional spatial arrangement of atoms or molecules are known as stereochemistry. So before moving to the stereochemistry, the most important thing is that these five most important things we have to learn, and then we will move to the concept of stereochemistry. So concept of hybridization, projection formula, conformational isomerism, optical isomerism, geometrical isomerism. So first of all, I am to discuss concept of isomerism. So as we know, the stereochemistry is the branch of chemistry that deals the spatial arrangement of atoms in a molecule in three-dimensional state is known as stereochemistry. So, before going to the discuss of stereochemistry, we should know the isomers. So, what are isomers? The phenomenon of existing same molecular formula but different physical and chemical property is called as isomer. The isomers are broadly classified as two types: structural isomerism, stereoisomerism. Isomerism are divided into two branch: structural isomerism, stereoisomerism. And structural isomerism are again divided into few types: chain isomerism, functional isomerism, position isomerism, and tautomerism. And stereoisomerism are divided into two parts: conformational isomerism and configurational isomerism. So conformational and configuration, as the name says, both are different, and we will discuss both these isomerism in a later on. So first of all, conformational isomerism are divided into two parts: acyclic and cyclic isomerism. Configurational isomerism are divided into two parts: optical and geometrical. So first one is functional isomerism, which is the part of structural isomerism. So compound that have same molecular formula but different in their functional group are known as functional isomerism. Means compound having same molecular formula but the functional group are different in both the isomer. All the isomers are known as functional isomerism, and the phenomena is known as functional isomerism. So one of the example is ethyl alcohol, and this isomer is dimethyl ether. Here, as you can see, OH hydroxyl group is the one functional group in the one isomer, and ether is the another functional group in the second isomer. So these are functional isomerism. Another one is positional isomerism. Positional isomerism, compound have the same molecular formula but different in their position of the same functional groups, known as positional isomerism. Means in if you are having a number of isomers, so with all isomers having same molecular formula but the functional group, the position of the functional group are different in all the isomers. So these type of isomers are known as positional isomerism. Tautomerism. So a single compound can exist in two readily interconvertible structures that differs in the relative position of at least one atom, known as tautomerism. So ketoenol tautomerism, ketoenol form is the most important example of this type of isomerism. Now the stereoisomerism. So this one structural isomerism I will discuss in detail in the coming lectures. In this lectures, I am discussing in brief each and every topics in brief, because we want to discuss stereochemistry. So the basic knowledge of the isomerism, if we know, then we can easily understand the phenomena of the stereochemistry. Another one is stereoisomerism. The phenomena of existence of two or more compounds have the same molecular formula but differ in their spatial arrangement of atoms or groups in a space is known as structural isomerism. Number one is conformational isomerism. So the arrangement of atoms of the molecules in the space obtained by rotation of single bond rotation are called conformations. This phenomena is known as conformational isomerism. Means in this conformational, isomerism conformational isomerism, there is no bond breaking takes place. You can change one conformation to another conformation by rotation of the bond, CC bond, and another one configurational isomerism. So configurational isomerism is a three-dimensional arrangement of groups around the stereo center, is termed as configuration, and the isomers are known as configurational isomerism. In this isomerism and configurational isomerism, if you want to change one isomer to another isomer, we have to break the bond. Then only we can change one isomer to another isomer. So I will discuss other one in the next lecture.